Oh, welcome everyone. Way to close the conference. So, talking about JupyterLab extensions today. As a show of hands, you guys showed that almost all of you using notebooks. So, a little bit about myself. I'm Jupyter. Oh, sorry. Gotta repeat myself, yeah. Talking about JupyterLab extension ecosystem today. Who am I? I'm a Jupyter user since 2019, since the grad school days. Earlier, Jupyter and Python user before I was doing some C++ and CUDA scientific coding. And then I became a contributor, maintainer for some projects starting 2019. Previously, before Anaconda, I built a Jupyter-based platform for National Institutes of Health, which saw 300 plus researchers using that. And I was involved in all of these extensions, and some more I didn't include, but both for professionally, as a hobby, as cool open source projects, and so on. Recently, built Auto Dashboards extension for converting notebooks to Streamlit, and at Anaconda, I helped to develop and maintain Gator extension, which I'm going to show later with my awesome colleague, Rosie Race. All right, and recently...
What does Gator do?
I'll get to that later. I have a slide for that. And recently at JupyterCon 2025, I helped to organize and run extension development workshops. So if you're interested in building those things I'm going to show, go check that workshop. It's fully open source and recorded on YouTube. And this are my cats, Holmes on top and Watson in my hands. They're giant cats. Okay. What is on the agenda today? Why we care about Jupyter, why we care about JupyterLab, why do extensions to that matter, and then I'm going to dive into what ecosystem exists for extensions, how does the discovery work today, and how I'm trying to change that, what does the data says about the health of our ecosystem, and how, at the end, how I build the pipeline. And I'm going to do a quick live demo. Okay, why we care about Jupyter? Jupyter Notebook adoption is growing. You see on the left chart at the GitHub, there are 2.4 million repos this year that have a Jupyter Notebook into them. And with the rise of AI, you see a rapid rise of Python and also similarly big jump for Jupyter Notebooks, which continue to be like leading format for experimentation in developing those AI things. Some might claim that notebook format is ideal for AI, is essentially for the training, especially because you have all that code and markdown next to each other interleaved, which help with the context for AI. However, on the right side here, from JupyterCon talk, we see the number of maintainers of vast Jupyter ecosystem. New contributors going down, returning contributors stagnate. So there's something going on here, and we may want to collect more data of what's going on. Why do we see such a huge rise, but maybe contribution not going up, or something is stopping it? Okay, so Jupyter, as I said, is a vast ecosystem. A lot of you, maybe show of hands, who of you use Jupyter inside of JupyterLab specifically? Okay. Who used Jupyter Notebooks in VS Code or forks of it? Okay, similarly, if not more. But for Jupyter open source project, JupyterLab is a flagship project. We switched from Jupyter Notebook some time back. We still maintain it, but it's completely was rewritten on top of JupyterLab components. So all the developer effort goes in the lab, and the notebook is kind of being, not backported, but developed together as a single view version of the lab. And here's like a brief history. I'm not going to go too much about how it evolved over the years. Okay, so what's cool about JupyterLab, right? JupyterLab is built from ground up on extensible platform consisting of different extensions. So the JupyterLab package itself is a collection of extensions, and it's built extensible inside and out, so you can install different new things on top of it. Since 2022, it's distributed as Python package. so you can install it and enhance your experience in multiple different ways. Most useful, most used, and most useful extensions are helping to do mostly those two things. So visualize data. You can use matplotlib in more interactive mode with IPyMPL. You can have your IPy widgets, the most popular extension for JupyterLab. You have interactive dashboards such as Voila. And you have more specialized viewers for maybe biological, astronomy, or physics, life sciences data in H5 Web. And you have Jupyter GIS helping you to visualize and bring advanced controls and bring it closer to closed source software, but fully in that same environment. Another popular thing that extensions do is to help you organize your code and do version control. So JupyterLab Git is similar if you use things like VS Code. It's similar UI-based version control extension. JupyterLab LaTeX is a love of mine, and I contribute some efforts with it, including working with different students to improve UI here. We have really cool things like Jupyter collaboration, which was a big effort, which still continues, where multiple users can connect and edit documents like in Google Docs collaboratively. You have things like Sidecar, which allows you to move your output widgets to a separate tab. Maybe for people who are not familiar with JupyterLab, you have all of this tab system where you can have multiple notebooks or documents and terminals open together on the same screen. And for the project I've worked at, Anaconda, it's called Gator. On this animation, you see what it does. Essentially, if you use your Jupyter notebooks and write Python Jupyter notebooks in JupyterLab, and you use Conda to manage your environments, you're going to have that UI similar to Anaconda desktop, Anaconda distribution in here. We actively work to improve it. This perhaps is an older version here. But you can create new environments, you can see the list of your environments, and you can update, install, remove packages, and so on. However, so I showed you a couple of star examples of JupyterLab ecosystem. However, if you're new to this and you're a new user, you want to find those extensions for yourself, right? How does the discovery process look like? So if you open JupyterLab, you see this panel. It connects to PyPI. So as I said, extensions are published as PyPI packages. And you're just going to have this list which you can search. It connects to PyPI, but unfortunately, there's not enough of information included here. You can find the same list by going to PyPI and searching for the Trove classifier, framework, JupyterLab extensions, pre-built. You're going to have the same list. And you have some filters, right? You have recency. You can sort by recently updated. Actually, this is maybe not correct because I clicked on some of them. If you click, you'll see GitHub connected, but not on a lot of them. And certainly, you don't see that on the list. You cannot see category at all. So as a Jupyter community, we never agreed on different categories of extensions. So that metadata just does not exist. And of course, someone trying to do that, even on their personal machine, but especially in a corporate environment, you don't know anything about security of what you're installing from here. It's just PyPI packages. And only sort you have is chronological. For inspiration of a little better system is Visual Studio Code, which has its own extension system with 85,000 extensions exist on the marketplace. And you can sort by recency. You get the recency signal. Still, interestingly, you don't see GitHub on here, like number of stars, and even though 2 Microsoft projects. You see the number of downloads here, like 78 million. And this store has categories. But still, you don't get any security signal. I know there is an application process to publish here. It's not auto-populated. You need to upload it and agree to uploading it. Maybe they do some security scans, and it's just not shown here. And you have some more useful things like trending sort to see maybe some new things coming up. OK, so this was my motivation to collect more data, maybe show it in a similar format, and let's see what I found. So this is the data I set up to collect. So I wanted to have PyPI downloads. I wanted to have GitHub stars, open issues, links to repo, easily accessible and findable. I wanted to have recency, but we already kind of get that. I wanted to find the category, and I turned to LLM to help me here, but don't treat it as a final verdict. It's my experiment, really. And I wanted to have some security. I'm not a security expert, so I turned to Snake Advisor, which seemed to scan every single PyPI package so I can link to that data. And I wanted to sort my data by all these interesting ways to sort the data, like trending or popular this month or versus overall lifetime downloads. OK. This is what I found. This is all the different categories I sorted extension and ASCII to sort them through. And I was curious about some of them, but most of the extensions, as you see, 28% of extensions are for development and version control, followed by cloud and platform integration and visualization, and dashboards are big. And then AI code assistants, it's a growing category, but it's still nowhere near others. So mostly it's used by, as I showed, as a productivity and visualization. And keep in mind, so this is a number of different extensions that people build, number of different projects in this category. So next I'm going to flip to the slide with number of downloads per category. I want to start with saying this slide is a little bit a lie. So IPy widgets I had to remove from this chart, and it's going to be off the charts somewhere on the next floor because it's 33 million downloads or something like that. So it's not even here, but it would be in this visualization bucket. So removing IPy widget, the most popular off-the-chart extension, what do we see? It's interesting to compare. I'm going to flip back and forth a little bit. We see that development and version control is appropriately popular compared to the previous one, and so is visualization dashboard. We've seen those are most dominant, interesting things that people do in JupyterLab. It's interesting to compare things like AI, education, specialized computing, and themes, which have multiple projects to them, but they don't see the proportional fraction of downloads. So perhaps this indicates that developers like to develop these things and do a lot of experiments, but they don't find their users, at least not in the numbers that would indicate that. OK, this is an auxiliary chart that shows those same downloads by category, but broken down for the last 12 months. And you can see, I think, interesting thing here that AI is growing. I think I updated my chart, and it looks very different. I apologize for this. It looked very different when I first built it. And AI code assistant was small fraction overall, but growing steadily. This looks a little bit different. So what are the top JupyterLab extensions we can see from the download data? I included the whole list of the most popular ones, but I want to highlight the same theme. The most popular ones helping you organize, version, and visualize your work in JupyterLab. Things like JupyText convert your documents from IPython notebook to Markdown or Python scripts and vice versa using Pandoc. As I said, widgets is the most popular one. There are some things that are not immediately useful outside of the environments they build for, like a SageMaker. OK. Let's see. So I wanted to see ecosystem health. So what's going on with, for example, number of new extensions, how people are building them. So on the left, this is a cumulative growth of number of those extensions over the years. It looks pretty linear. And if you break it down by month, you see nearly constant activity, people trying and building new stuff, except for the last 2 months. I guess with AI, people just trying to do more stuff. There was a JupyterCon, but we've seen a huge, huge jump here. All right. This is very interesting. So I was thinking about how to look at the data, and I decided to plot all of the extension I had as the age of extension versus the lifespan. So the age of extension, so this old stuff will be here, very new stuff will be there at the 0. And the lifespan is how much time went from the first release to the very last release up to the date. So how to look at this graph? So anything along the red line should be in good shape, recently updated, and since the very first release. So I labeled them green. Stuff that hasn't been updated more than a year, I labeled gray, and I put the size, download size, as the size of that bubble. So this gives us a very interesting look at the ecosystem. First of all, you see, what we want to see is those large green bubbles, which will indicate the things that are useful that people are downloading are well maintained. So we mostly see that. Both older and newer projects that are very popular are very well maintained, which is expected correlation perhaps. There's some big gray bubbles would be maybe a cause of, maybe not necessarily cause of concern, but something to scratch our head and think like, what's going on here? And we can look, and some things are just haven't been updated, and it could be, I think, for two reasons. So one is really real maintainer burnout, and no one is just maintaining it, even though people find it useful. Other possible problem, it would be stuff was built and kind of contains whatever it needs to be contained, and whoever built it thinks it's done for. Yeah, so things like Jupyter Server Proxy, we had a conversation at JupyterCon, it's going to be updated. And this stuff, when stuff gets updated, it jumps up. Also interesting, down the below near the x-axis is all lots of those gray dots, which shows like a graveyard of a project which were released once and never updated before. And then there's the stuff in between. So I think overall it shows a healthy ecosystem, but with those big gray dots may need additional attention from us developers and open source community. I like to visualize it with a picture of a forest because we talk about ecosystems. Forest is an ecosystem, and all those green leaves. I thought this is a picture of Yosemite National Park, and you have the leaves up here, and you have like that project there as kind of like a mulch from which people explore their ideas, but maybe new ones will grow up soon. Okay, now I'm going to switch to a demo. I'm going to show you the website I built from collecting this data. Let me reset all the filters and maybe perhaps zoom a little bit more. How's this looking? Can you see everything?
Yeah.
All right, so I collected all this data I talked about, right? And we just looked at. I wanted something similar to what VS Code users get to enjoy. Both users, especially new users or experienced users, looking to find better tools for their workflows. And also developers, if they publish an extension, I want to know if anyone downloading it, what's going on with it, right? So all these AI calculated AI-generated categories are up here. We filter them by all. And you can see overall there's 908 extensions, minus stuff that I filtered out that's known, like broken or bad extensions. And then on the latest version of JupyterLab 4 is 648. Just to give you an idea of that linear growth, right before JupyterCon in the end of October, we only had 600, so just 48 new ones appeared. Let's see what's really popular, right? So the stuff I talked about. So this one is interesting. This is a theme bundled with JupyterLab, but not bundled, but shipped as a dependency. So everyone is like a proxy for JupyterLab downloads. Everyone downloading JupyterLab will download this. And I have to preface all of this that looking at downloads. The downloads are not installs, perhaps. Like it's a little bit flawed metric. You may have a lot of CI/CD pipelines running and pulling your stuff. So, and it's all also applicable to any of your other Python packages you may look at. You see JupyterLab widgets is absolutely the most popular, followed by JupyText, AnyWidgets, HoloWiz, Matplotlib extension, NBDime, and JupyterLab Git for working with Git, PyPI for running things in parallel, Jupyter Server Proxy for proxying other application in your environment, language server, Jupyter AI Community Project, and so on and so forth. I like to look at recently updated. This way you can see what was new, what was recently published. Big kind of news for me was that a lot of quantum computing folks utilize JupyterLab a lot because they seem to produce a lot of those different extensions for it, like a Q-sharp and some more of the others. Okay, let's search back by popular this month. In the AI category, which certainly has the most interest from folks, we have all the different tools that people create, but some of the things I never heard about. And let's do a little demo, right? So let's say you are a new and aspiring JupyterLab user, right? So you might want to install JupyterLab on your notebook like this. And then I'm going to go to the marketplace, pick up some extensions that show how you install them and how they're going to show up in your environment. So I'm doing install of Conda environment, PyData Boston. Okay, let me see, it's activated. And let's go back and pick up a theme. It's really easy to install. This looks like a cat. I like cats. So if you see pip install command here, I'll show you later what I would really want to have here, but for now I can just copy paste the command and run install. Hopefully it's not a virus. Well, we can see that, right? So whatever, for what it's worth, Snick Advisor thinks package health is 52 out of 100. If you click on that, you're going to see that that they put multiple signals into that score, so we know security is no known security issues. At least that's good. So who of you took one of the earlier workshops on Monday? Some people did. So I noticed in some of those JupyterLab for NVIDIA training, they used a bunch of JupyterLab extensions. I think there's a one for cell timing somewhere. I hope it can. Yeah, I think this one was used a lot. So this would show up at time, so you don't need to type time it. It will show a tiny gutter with the cell timing. Maybe let's grab MyAI from our friend Jake here.
Hello.
And try to install it for AI Assistant as well. And then so once all of this installs, we're going to launch JupyterLab, and we're going to see our theme, our extensions, and so on. So it's pretty easy to install with Conda, pip, OUV, whatever, but it's all Python wheels. How are we doing on time? Good. Okay. All right, so let's check if we get what we asked for. Okay, so there are multiple cat themes. Let's check a latte. I'm going to totally derail my own talk by like checking all the cool stuff. Oh, I love that. Okay, dark theme. So you already see MyAI. It might have cached my previous attempts here. So let's start a new chat. Like, hi. And then let's run something. And we're going to see the cell timing here. So all the three extensions we found, we were able to install them. OK. That's enough of the demo. Let's go back. All right. So the last thing I want to, few of the last things I want to talk. So who I built this for, right? And maybe most importantly, I mentioned this website, right? So you can go to that website. You can type labextensions.dev. That will open this. So it's free to use. I don't charge anything for this. And I'm the only person running this. And then let's go back. So who I built this for, right? The catalog data set. One is Jupyter users, new Jupyter users. During the hallway track here conversations, a lot of people just don't know about extensions existing, and they may be missing out, or the Project Jupyter may be missing out by not advertising that enough. So if more people know about it, maybe JupyterLab will be more popular. And for extension developers, for sure, you want to see how you compare. If you build something, how your downloads going. Do you have a huge community or a small community? You want to know. And finally, the pipeline. So how I collected this data. This was an interesting journey on its own. So it turns out every time you type pip install JupyterLab git, right? Whatever pip install command, you go to PyPI, but what PyPI does on the back of it, it sends a timestamp, an event, or download event into a large table which contains a package name, package version, timestamp, and maybe some other information there. Through what's called line hole project, it goes into Google BigQuery table, which is an enormous table, as you can imagine. It's how many people download stuff. It's over 2 terabytes. But it contains like full raw unaggregated data. And it's available for everyone. However, it's on Google Queries, so you pay per byte for processing. And what I did is I built my own script here to run daily and aggregate all the new downloads for the last day. So now in my table, I have package name, package version, number of downloads for that day. And then I use GitHub Action script to pull all this data from BigQuery into my intermediary JSON. I have a block list. There's this crazy stuff. I block some extensions there. But then I have in my intermediate data set a list of all JupyterLab extensions along with their downloads. And then I can go and try to enrich them with the GitHub data. So I look for package metadata. That's why package metadata is really important. I pull GitHub data, and I found the GitHub repo. If that exists, then I can use GitHub API to find repository data, stars, forks, issues, and maybe more information potentially in the future. And then I try to do AI enrichment. It says Gemini. I switched to a different thing. I'll show later. But anyway, so you can send the contents of the Python wheel and all metadata you have to AI to try to gather some interesting information. I don't fully trust it, but I'm still experimenting with it. I think categories are OK. Other stuff maybe not so much. And after all of this 3 GitHub Action scripts, they all run daily, all run together. I upload it to Supabase database. And of course, it goes to Next.js website that I showed you. And then you can find your extensions. And when you install them, the loop closes, and we continue collect information on extensions, right? This slide on AI classification. So basically, I already kind of told you why we need this. But there may be other ways to solve it better. For example, we should agree on different classification and perhaps formalize that metadata, and so people can start classifying their stuff on their own. Some extensions just lack proper stuff. It's PyPI, or anyone can upload stuff there. And so for what I did is I ran LM, I download Python wheels, and send this old giant prompt to LM. And I try to come up with those things. So categories, I said they're mostly OK. Funny stuff was when I tried to ask it for code quality, and everything came up as 7. So don't trust your LMs to do scoring. Sometimes maybe. A little bit about cost. So I built this myself, and I'm running this on my own. So there's a cost associated with BigQuery, and there are costs associated with LMs. So for BigQuery, I initially burned all my Google Cloud credits because I just didn't know what I was doing. But if you know what you're doing, and the actual initial aggregation table fill for the last year will cost you about $20. That's a place where I really wanted PyPI to kind of provide this data for us. But you can do it. And if you ever use things like PyPI stats or pepi.tech, I think they're doing exactly the same thing to give you those download graphs for Python projects. And then it costs about $1 per day to run that daily script to get the new uploads portion for the last day. For the AI enrichment, unfortunately, run into folks from Dip Infra, and they gave me some bunch of credits. But I really didn't need them because each extension, I didn't really use them because it costs half a cent to analyze each extension, so about $4 total to run this classification of extensions using LM. And I think I used DeepSeek version 3.2. Okay, so the Supabase data I showed you, all the data that powers the catalog, it's available. I left it read-only for everyone. So if you want to, run some data science project and look at this data yourself, feel free. If you go to the repo, you can find all these keys, and you can pip install Supabase or use SQL. Exciting stuff. So future directions. What I started the project with is the thing on the left. You go to VS Code Marketplace, and you find something, and you click install. Your VS Code opens, and you click install there, and it installs. Well, I wanted the same thing, so I showed you, I copied the pip install command, but what I really want to do, this thing can do it for you. I just need to connect the dots. I have a catalog existing, just need to connect the dots. It probably will involve, contributing to JupyterLab to allow something like deep links or something, whatever VS Code is doing. There's additional challenge that your JupyterLab is not a desktop app, so it can be running anywhere. But I've seen other cool folks from Home Assistant solve this problem, so I may attempt to do it later. We want perhaps maybe better security scoring and scanning, but I'm not an expert again. Yeah. All right. And that's it for today. Thank you so much.
Why is it your marketplace at JupyterLab is extension so you can click install?
Sorry, what?
Why don't you make your marketplace a JupyterLab extension so you can click install from there?
As I showed, right, you don't have enough information there, right? So it's very poor. You can find the name if you know the name, but you have where was it? Right? So in JupyterLab, you have this.
No, but make the viewer, make a JupyterLab extension.
Inside of JupyterLab.
That just views your marketplace, and you can click install.
That's probably a good idea. I don't know why I didn't think about it. Now it makes so obvious and feels so stupid for not doing this. I think it should be easy now.
You have to start somewhere.
I'm curious on your thoughts so you showed that there's this big increase of downloads and including Jupyter ecosystem due to AI, but then there's not an adoption of the AI extensions, and I'm curious why you think that's the case, because I feel like people are definitely trying to use it with
people trying, yeah. I think so. Maybe the biggest AI extension in the space is Jupyter AI. And they went through the process where essentially folks from AWS was running it. And it was using LangChain, and a lot of people kind of turned away from LangChain. And now they're in the process of making it way more modular and better, but the time was lost. Oh, sorry, Jake was first.
No, go ahead.
You mentioned at the beginning about that you got the data from PyPI,
yeah.
Right? So do you think that if you consider from UV and other installations, do you think it would change the?
Yeah, so that's an interesting question, right? So some of the packages, like any widget, can be used by Marimo. And I cannot differentiate from PyPI data who downloaded it. So once again, those data is messy and is skewed perhaps in a way I cannot understand. JupyterLab is open source project. It doesn't contain telemetry. If there was a telemetry, we could have collected this, but I don't know if folks would agree to that we need to add telemetry to open source, IDE.
Yeah, thank you so much. That's very valuable data. Thank
you. Yeah, I'm wondering. It's a little tangential, but do you know if Jupyter AI or AIs, do they have a good understanding of how to recommend what extension to use? So you put a prompt that maybe has something to do with quantum, like you were talking about. Will ChatGPT or Jupyter AI recommend, oh, there's this extension you should use? Does it have good information on that?
No, I don't think that loop was ever closed or even considered.
Thing too.
Yeah, because if
Make
you
it
already use
discoverable.
AI, you may surface this information.
Yeah, even
I
like
don't-
as you're writing code, it could like recommend something.
Yeah, I don't think
that's
any
successful.
system does it. Like VS Code, I don't think you can go to Copilot and ask for cool extensions to install in VS Code. I might be wrong,
Yeah,
but
interesting. That could
yeah.
be cool.
It's very meta.
Yeah.
Do you like discover anything about the like people that are contributing to this ecosystem, or have any like insights like about the type of like what is someone doing that they
I find it very interesting. So I think I found the person behind this large spike I showed on the monthly graph.
Yeah.
So if you go search by recently updated, there's this user, Stellar Henson. I don't know him. Maybe he's here. I don't know. But he published, if you see his picture, there's a lot of extensions he published. Lots and lots of them. I went and checked on GitHub. He was using Claude, so for its work. And then it doesn't seem like a slop project. They seem like genuinely useful ideas he might be exploring. And that's one of the things I forgot to mention, is because of JupyterLab is built itself from the collection of core extensions, people developing extensions, like third-party extensions, they become more likely to contribute to the core because they already know all the ins and outs. So there's like a pipeline to create new developers to JupyterLab itself. That's why I also wanted to encourage people to build stuff. And yeah, so if you want to see a tutorial, so if you want to build something like this yourself, go find JupyterCon 2025 extension workshop. So we ran it in November, and we put everything open source with open license, so you can go see our materials and learn how to build extensions from scratch. Yeah.
So I'm confused again. I am a Jupyter extension author. I see any widgets up there. I didn't think I was a JupyterLab extension author, but any widget's up there, and I don't think any widget does anything with JupyterLab. It just works in the notebook.
So here's the thing, they mark themselves with that metadata.
Ah,
So it's all about metadata, and
would you consider any widget a JupyterLab extension?
we can quickly check. They might have some hooks that actually connected. So the way to really see, so metadata is like first pass, but it's also like faulty. Some people may not put it in. But if you look at this, so we might want to find a dependency. So if you search for JupyterLab, and we find it in package JSON, that would be a strong signal for us.
Sorry,
let's see.
this is through.
They have something related to JupyterLab in their package JSON, so they might be doing something. I assume it's not just,
Okay.
yeah. Although I don't see them in actual dependencies, so I don't know. It might be like a hook to advertise it to, so people would install it. So there's a little bit of split. So I talked about things like JupyterLab extensions. So it's a full stack apps. They target TypeScript on the front end to interact with the interface, a modified interface. And there's a Python backend endpoints. And there's also Jupyter widgets like yours, right? So in Jupyter widgets, they don't have that metadata, I think. Maybe, I don't know. I think this needs to be revisited. And those metadata tags on PyPI, they just contain in a repo, and you can totally propose new ones. So it's something we perhaps should do. But the widgets, they live in the cell outputs. They also can interact with Python and have both components, but those things are different. And it's sometimes tricky to explain the difference, even to people working in this space. So
Okay.
for what it's worth, it's like that.
Cool. Great. Thanks so much.
Thanks, everyone. This is PyCon.